coming out to this talk. Few in number, but will make for better conversation, I think. So, as some of you might know, this is last minute. I got asked to fill in for somebody that couldn't make it. So, thanks for coming up. I'm Dwayne. I work at Pantheon. Been there since 2014. That's actually where I picked up the skill of Git. It is kind of a byproduct of working with a Git flow enforced, or a Git-backed workflow that's enforced. Is you just learn how Git works as a natural byproduct of that. And then I dug into it and found that I really, really loved it. So outside of tech stuff, if you ever want to talk about crochet, I love talking about crochet. It's my favorite thing right now. Come on in. I love karaoke. Hopefully we'll go again tonight. We went last night. It was so good. And I am on Twitter at MC Dwayne. And I actually have a request, if you guys wouldn't mind. Somebody could take a picture of me in front of this picture. This is an ongoing project I have this year. Like, yeah, if you wouldn't mind getting a portrait, it could be, yeah, landscape. Landscape is the way. I hate to waste everyone's time, but this is you can tweet this at me. This would make my entire day.
1, 2, 3. Same shirt.
Yeah. So I started Pacific Northwest Drupal. Chris Teasel suggested that I do this project this year, and I am. So every time I've spoken, I've taken a picture of me in front of the last time I spoke. It goes all the way back to the beginning of the year. Anyway, enough silliness. Anyway, yeah, I work at Pantheon, and we have a Git-based workflow. And some of just how Pantheon works just makes more sense once you understand the base concepts of Git. Since we have this ability called multi-dev, which we can spin up multiple development environments around your Git branches. But if you don't know what a feature branch is, that is just confusing. So that's part of the goal of my talk. But I have a lot of other goals for my talk I'll get into. But I'm curious to why you came in this room. Like, you had 3 other options of things you could have gone and done, plus the hallway tracks, plus whatever else you could have been doing on a Saturday. So why this room? Why Git? There's only 4 of y'all, so.
My coworker thought it'd be a good idea if I did.
All right. Do you use Git at all right now?
Nope.
All right. All right.
Kind of same thing. I have to use it now, but it's a new thing for me. So
Okay.
like I'm using a few basic things, but to understand the workflow would really help because with this branching thing,
Yep.
sometimes I'm just not sure. Like I'm really.
I gotcha. Okay. Awesome. Either of y'all.
All right, so I came in late, but
No worries.
I took a Git class about 8 months ago.
Okay.
It was great, hands-on all-day thing. So
Mhm.
it really felt like I got it. And then I went back to work and I never used it. This week I installed the Pantheon, like an area of sandbox on Pantheon. Could not figure out how to get from Pantheon into my Git account. I just could
Sure.
not get the command. So
Okay.
I'm kind of hoping if there's
We'll
time-
point you in the right direction, hopefully by the end of this. And not to Pantheon specifically, but generically how all Git repos
Yeah, how do you
coexist.
get
Yep.
back and forth?
We will definitely dive into that. We have a full hour, so we will be digging into that. All right, Self.
Well, I'm very new to Drupal and
Oh, awesome.
and everything else, so this is the first time I've actually been in a camp, so I'm just here
Oh.
to kind of familiarize myself with everything.
Well, that's great. Well, welcome. There's tons of great knowledge. This community is amazing. Feel free to always ask questions of anybody about anything, and we're here to help each other. So, I always like to start with the why of a thing, because I always think if you don't understand the why or care about the why, then the how really isn't. We don't need to go into the how, because you'll never care about the why. So there's a set of problems that exist, that have existed for as long as we've been able to write things down, edit them, and save those states. This is the classic example of, we've all been there at some point, where we're passing a doc around, and you just keep renaming it, and renaming it, and renaming it. And eventually you'll have a final version, but calling it final is kind of ridiculous. And then once we get into collaboration, So I should say this talk is not just for the developer. I'll get back to that in a second. But anytime we're collaborating across anything with a document, we're saving the document, or creating the document, saving the document, editing the document, saving it again, such as a text file. If we're using Dropbox in this example, who wins? Who wins here? Yellow or blue? Blue. Why? Yeah, last save. They win the last timestamp. What happens to all of Yellow's work in this Dropbox scenario? Overwrite it. It's gone. There are some tools like Google GDocs, Google Docs that help prevent a little bit of this, but it's still not a great system. And then this screen we've all seen at some point in our lives when we've changed a file and uploaded it. This is the white screen of death. We've all been there. We've broken something, not meaning to, but all of a sudden the site just stops working. And hopefully we'll get an error message. At worst case scenario, we won't. And ultimately, we all have to undo things at some point. Now, if you're working in a local document and you made a typo, well, there's this great thing called Command Z or Control Z, depending on what system you're on. But it's the undo, and it's awesome. But it's a tactic. It's a very specific point-in-time tactic that works up to a point. It works in the same document back a ways. It depends on what program you're in. Sometimes you can go back to the beginning of time when you started working on it, but as soon as you close the doc and reopen it, this stops working. So we need something that's persistent across sessions, and not just your sessions, but everyone's sessions that's ever touched this document. And that gets us to Git. Git was designed to literally solve that problem set of how do I pass documents around in a sane way where I can track changes over time and we can undo things if we make mistakes. So if you go to Wikipedia, this is the definition, which is great. It actually is elegantly written, but it's really dense. It's like, what's a distributed version control system? So the story of Git is pretty interesting. You can go read a lot of stuff out there, but the very short version is that Linus and team were working on Linux, the Linux core kernel back in 2005. And it was really painful because the team got way too big for a centrally managed repository to make checkouts make any sense, where we would have only one person could edit at a time. The system was just too big. It was clunky to work that way. It said there's got to be a better way to do this. What if we handed around the entire set of files across the entire project and could keep those in sync in a sane way? And that was the conversation that started with whiteboards with this guy, Junio. In fact, Linus says that the smartest decision he ever made in his whole life was putting this guy in charge of the Git project. And he's still in charge of the project to this day. He's actually hilarious. He's very subtle in his humor. But if you go read the pull requests from toward the beginning of the project, it's like there's a little humor packed in there. He's a nice guy. Never met him. But they worked out on a whiteboard that there's this concept that goes beyond developer. There's a concept that goes to this, anytime you do any kind of work against a document, something called a knowledge worker. They didn't invent this concept, but they realized that that's what this is. That's what we're really addressing here. It's not just a developer. It's not just for a certain kind of thing. This is a really general, almost library type system, organizational system that will work across any kind of docs, no matter what you're throwing at it. Not just for devs. The basic idea is very, very, very straightforward. And I've already said it several times. We're going to create a doc, we're going to save a doc, we're going to edit that doc, and we're going to save it again. And then there's this layer of Git that does this. It tracks every modification every time you save it. It knows every state that's ever been saved. And we're going to include the state of the document before and after the modification as well. So that history is going to let us look back in time, see what's happened. And it's going to let you actually write down why you did what you did. And talk to yourself in the future. That's who you really should be writing Git commits for. But really, you're communicating with everyone else that will ever see this repository ever about why you did what you did. The larger your team, the more important it is to be verbose with this stuff. So without having to go and read the code, you can see a very simple message that says, we did this. And you know exactly what's involved in that code. If it's robust enough, then this is a great system. The worst thing is made change or change this file, but to say nothing about it. We'll get into more of that later. But really, we're not ever talking about a single doc. We're talking about a project at a time. We're talking about putting a module in. What's the minimum number of module or files you need for a module to exist in Drupal 8? Anybody know? I don't either, but it's more than one. That's just the way Drupal 8's working. So Git lets us apply that same principle of like I changed a doc, saved a doc, to the entire project at once. So if I changed 32 docs, just a random number, 32 docs, text files, in the process of making this change to my website, I can document all of that at once. Or do it iteratively. And the basis of Git really isn't super overly complicated, and it's based basically on the old time travel theory. Or I shouldn't say old, but just generic time travel theory. That we can go forward in time, we can go backwards in time, and we can branch off into these parallel universes that result from changes we make when we go back in time. Or can branch off into just parallel multiple universes. Git is literally graphical based. I don't have... yeah, I do have a picture here. So you might run into this. This is your best friend with Git. Ultimately, everything in Git can be mapped to a chart like this. Literally a map of what's going on. It's just learning how to read a map. Like if someone handed you a map from a foreign planet written in their native tongue, you might recognize it as like, this looks like a map, but you wouldn't have any idea what the lines mean or what the symbols mean on it. It would take a bit to learn. And that's what I'm hoping to encourage y'all today. Like, we're learning how to read this map and learn how to navigate this map. And that's what learning Git's all about. I'm going to look we'll talk about like the how of it, but if you ever get stuck of like, well, where am I in this world? Just know that you can always draw circles and lines on a whiteboard. And if you can't, then something's terribly wrong. Because anybody that's explaining a project to you and they're explaining, well, we're in this feature branch, like, well, can you draw that out? They should be able to produce this. Or they have a tool on their machine that will just generate this. Because there's a lot of tools that will just build this for you. But I'm not going to talk about the graphical base that much more today. But know that it works like any other number line. There's a, 1, 2, 3, 4 along the path. And we can branch off that and go back in time. Over talking that point. Very important to remember, and this is different than a central controlled version system. Everything's local. Literally everything. Which means that when you clone a project, you cloned every line of code in that entire project. You're not just pulling one file to work on. You're pulling the whole darn thing. It also means there's no central true version of anything. The version you clone down is the project. When you clone Drupal 8 from Drupal.org, that's the project. Now, which version is in charge, which one we say is the master version of that, the truest version, that's a human being decision. That is humans saying, all right, I have decided that this is the one that we're going to lock down the permissions of who can write to this actual server in this location. But that's not really an internal Git decision. Git doesn't really care. Git just knows that there are like 50 copies of it out in the world. And we'll talk about later when we talk about remotes, how those all interrelate to each other. But none of them know they're in charge. They just know they exist. So everything is always, always, always local. Git is super lightweight. If you SFTP a file across the wire, you move the whole file. So if you have a 10K file and you change 2 characters, how much do you have to push across SFTP? 10K, that's right. Thank you. With Git, you only move deltas. You're only ever moving what you changed. And a little bit of metadata above that. So if you change 2 characters, what you're pushing across the wire is a Git diff that is just a little bit of meta that explains how it lines up, and then literally the change. So you're pushing 2 deltas and a little tiny bit more. Super ultra lightweight. So you're moving literally handfuls of bytes at a time, or you can be. So this comes super important when you're moving you're making large changes across the project, across multiple modules. You're only moving the little bits that you change, not entire modules at once. I wrote this talk more for the WordPress community, but it's a valid point nonetheless. Git is not a website backup tool. It backs up your code very, very well throughout history, and it's great for that, and that's what it's meant to do, version control for your code. But a website's more than code. It's a database, it's file structure, it's other third-party integrations and whatnot that live in the database, but they don't live directly in code. Just know that you got a great code backup tool, but not a backup tool in general. I'm not talking that. And don't worry, if you ever get lost with Git, there are hundreds of thousands of resources in the world for you. It's the best documented project I've ever seen or ever heard of. And it's not that old, weirdly enough. It's 13 years old as a project, but there are more tutorials for it than pretty much anything else on the planet. Because it's super useful. Right now, it's got 80+% of all developers on Earth use Git in some way. Tangentially, maybe, but that's the numbers that I've seen. So how do we use this thing? That's what the whole rest of today is, and I should have said it earlier. How you're going to get the most out of this is having machines open and just play along. I'm actually going to talk about code and doing this with code files, how much, other than maybe an index.html. Because it doesn't matter what the text file is. In fact, how I personally use this a lot is for content. I write everything in markdown files locally, and then use Git to manage how those exist, and push them and store them on GitHub. But it has nothing to do with code. And that goes back to the idea of knowledge worker here. Any document you have, period, can use Git. Any file can too, but you lose the advantage if you have photos, for instance. You're not going to change a delta on a photo. You're going to change a lot of things on a photo if you change something because you're going to apply Photoshop to it. And it doesn't really make sense to store a giant blob that you're just going to replace the entire giant blob next time you update it. Now, that's what other systems do really, really well, like optimized systems. So if you don't already have Git installed, if you're on Mac or Linux, you probably already do. But if you don't, go ahead and install it. These are the links if you're playing along at home with the slides, because we are being recorded. Pick your flavor and download it. I'm going to talk about the CLI. It was invented as a CLI. It was invented to you can stay in terminal and do all of this. I'm going to talk a little bit about the GUI side of it. There are a lot of local GUIs, and then there are online tools that built on top of Git, like Github and the repositories and whatnot. The Git GUIs are great though if you like GUIs. If you need a command line tool, if you like command line tools, stick with command line. There are some advantages to these over native in terminal Git. Some of these include some additional logic tools on top that sort out things like Git conflicts for you, or merge conflicts for you. We'll get into that later. Or just make it a little bit easier. So visualization, I showed that graph earlier. These all have that built in. You can just look at a graph view and see exactly how the thing is structured and where you are in the tree. Let's talk about just dig in and talk about it. So if you're just in a file and you have Git installed, you can just say git init. And git means initialize the whole kit and caboodle Git process. All of these slides, the way they work is I will talk about the concept, and then there's an animated GIF that's not really meant to be stared at and read right now. When you're at home later, you can see a working example, exactly how it works, and it will just keep looping forever. But in this case, we're going to make a file called .git. Git init does this. So I'm on Mac, so that's a Mac structure, but it works the same everywhere. We make a hidden folder, a .git folder, that contains all of this great stuff. I'm not going to dig into what all this stuff is today. Again, brilliantly documented and you can read a lot of theory on this stuff. All you really need to know is this is the metadata that Git's keeping around on top of your changes. And this is where it stores those changes over time in these folders. And there's the special folder here called head, or not folder, file here called head, which is really small. Look at this, 23 bytes. It's tiny. That tells Git where reality is. That tells Git, this is where I think we're talking about now. So you will see pretty quickly when you start using Git, the ability to get into detached head states. It's not that scary. If you're ever in a detached head state, all it means is the head file is a little confused on where it's supposed to look. And you can just tell it, like, just look here, and it'll be like, okay, I know what to do now. That's all it really means, is like, I know what we're doing because the head file says this is what we're doing. There's a great tool built into it called status that will tell you what is going on no matter what else is going on. Like, it will just tell you the status of the world. You can run this at any time. Never fear Git status. It's your best friend. If you're ever confused on where's things like, just run Git status. In this case, it's telling us, if you can see it, that we made an initial commit with nothing in this file, and then we created these things which Git can see, but it's not tracking. And that's where we get into the base concept of moving forward in time. Honestly, this is 90% of Git. This core concept plus one other command is what almost everyone does. But the easiest way to explain this, I think, is think about an actual physical desktop. If you're in a command line, there's a command pwd, present working directory. So that's where working directory comes from here. It's literally the file you were working in on your machine. But we can kind of think of it like this desktop here, this actual physical manifestation of a desktop here. Git can see everything going on, and I can keep moving stuff around it, but until I tell Git, it doesn't really care how stuff is arranged. It's like, yep, see there's files there. But you say git add, and it says, okay, I need to pay attention to right now at this specific point in time. I'm going to take all of this and track exactly where everything is, and that's going to be reality of my Git stage. I can take that stage point, my staging area that got created out of that. So you can almost think of like I took everything on this desk, made an exact copy of everything as it is, and put it in a file folder. And then I'm going to commit that into my history. And that's like taking a magic marker and writing on the outside of my file folder, this is what's in this file folder at this point in time. This is why I put this here. And then I can make some decisions. Like I keep working, and I'm moving stuff around. And then I'm like, okay, this is how it needs to be now. Well, I'll put this over here just to make some bigger changes. This is how it needs to be now. Now I can git add. And again, we're putting this in a new file folder. But then I realized, hey, wait a minute. This needs to be over here. All right, I'm going to save again. Now I'm going to git add again. And now this is what's in the file folder. I can keep adding this file folder all day. I can keep modifying the stage as often as I like and as much as I like. But eventually I'm going to get to a point of like, this is the final. This is what I want the new reality to be for this project. I'm going to git commit, which means I write on the outside of the file folder. This is exactly why I did what I did, and this is why it's like this. Great. And then I can go back, keep working. But I can take that commit and do something else with it, like share it with someone else, or deploy it, or that's the final version of it that I've got done with and say, okay, I'm done for now. Not done, but done for now. And then you just iterate this over and over and over again. Make some changes, you save, you add, you commit. You make some changes, you save, you add, you commit. So when we adds a specific step. So we can add individual files and say, hey, I only want to add this one file. So don't pay attention to anything else. Like just pay attention to this cup. Git add just this cup. Because I don't want to care about anything else. Like that might change, but I don't really care. Or I could say git add in the entire directory. So period in bash means the current working directory, or present working directory. So this and everything below it, just add everything you can see git. I use this a lot, actually. Is it best practice? If you're working on a big project, no. You should be adding individual files. Just change what you meant to change, or add what you meant to change. But if you're working locally and it's your own project, you're working in a couple files, git add dot saves a little time. There's no one true 100% right way to manage this stuff. My favorite expression for it is there's a lot of ways up that mountain. There's a lot of paths. So there's not one true, like, this is how you have to do it. There's a 100% one true way for your team, though. And this is, again, where Git kind of stops and gets a machine. These are conversations you need to have with your team for proper DevOps. It's like, how should we be doing this stuff? Like, what is the proper methodology here? Which leads us into git commit. So when you actually type git commit, you need to throw a -m flag, the M flag, and then, in quotes, write your message. Now, I'd say, like, wow, you're throwing flags at me already if I'm using command. It's only one I'll throw all day, like talk about specifically, but M means I can write my message in line. Just one line and just do it. And then it's very straightforward. And then my commit is done, and I don't have to do anything else. So here we go. Then my commit got made, and yeah, then I'm on. My git status shows me that I got committed. If you don't throw the M flag for message, you will get thrown into your default editor, which unfortunately on most machines is VI or Vim. To this day, the #1 search thing on Stack Overflow is how do I quit Vim. It's horribly confusing if you've never gotten used to it. But eventually you'll learn it's I escape :WQ for right quit, or :Q exclamation mark to just quit. It's actually extremely powerful, and if you like memorizing 1,000 hotkey combinations, this is probably your best editor of choice. So one of my better friends in the world, not as VP of tech, but he learned it deeply, and it's a really powerful tool, but it's very confusing. That's a little side note. But after we modify our file, again, we just repeat this ad nauseum, and that's how we go forward in time on projects. And then there's git log, which shows us what we did. Git log has a couple forms to it. There's git log, where we'll show you, actually, let's switch over to live demo real quick. Clear, make this bigger. Change directory. Download. Oh, it's not download, it's docs. Yeah, so this is, I showed that site earlier, kevinthal.com. Trying to get status. It thinks it is, but I'm going to do a git pull real quick. I will come back to that. I'm kind of ahead of myself because I wanted to show this clear. And git log. So I can see exactly who's done what on this project since the beginning of time. So I did this morning at 9/11, this time zone. I merged a pull request that JD Doves Dev, JD Flynn, did on the site, and there is the commit message that he wrote. Add instructions to stop after session. That's a good pull request, so I accepted it. He also wrote some other changes in the past, reverted a change that he made earlier, but I can see the exact project going all the way back to the beginning of time. This really long line up here, this is the secret sauce that makes Git run. Everything you do in Git gets a unique ID. It's a 1 in 3, over 3 billion chance that you'll ever replicate that ID number. It's only been done once and in a controlled lab environment where they forced a collision just to prove you could do it. But in the wild, it's never happened. Internal to a project, it will never ever happen. Like, it's absurd that it would ever happen. That's a really long number. There's also this other way to do this. Let me clear that. It's called git log one line. Oop, forgot to throw the flag. It's two lines. Git log one line shows me a shorter version. And that's my entire Git history with just the commits thrown out, or commit messages, and this little short ID. This short ID maps to the long ID. So if you ever need to do anything with an ID, I recommend this, because Git knows what you're talking about. It's like, oh, I know what commit that is. Likelihood of these two colliding is slightly greater, but it's like 1 in 320 million, I think. So it's not likely at all, but short IDs will ever collide. Slightly more than longer IDs, but is what it is. Internal to a project is probably never going to matter. You can always assume it won't. All right, so that's seeing back in time. I can see back to the beginning of my projects. And then the last thing to know about going forward in time is checking and see what you did that was different between when you last added and where you're working now. Or last commit and where you're working now. So I'm doing some work like, what did I actually change? You can run git diff and it will show you exactly what you just changed. In red is what you took away and what green is what you added. Now this is where Git gets a little bit weird from a conceptual perspective. Git doesn't know the concept of adding single characters or removing single characters. It removes or adds entire lines. So by adding a new character at the end of hello world, it actually deleted the entire line from what it thinks happened and added a whole other line with a new character at the end. Still a handful of bytes. Still super efficient. It's also really easy to read. So rather than trying to search for what is the weird little one character I changed in this line, it's like, oh, it's just that entire line is red. Makes it pretty easy to visualize. There's also Git, and you can throw the flag staged to see what's the difference between what you've added and what's actually been committed. So just Git diff shows you just current working directory versus commit. Git add stage means what's in my stage that's different than what's in commit.
What's the command git add stage?
What?
What is the command for the stage?
Git diff -- stage.
Okay.
Or staged. If stage fails, it's staged. I think it's staged. With a D, I think. All right. That's it going forward. That is, again, the bulk of what you need to know. However, that's not where it gets confusing. Git starts getting confusing when you start doing everything else with Git. Well, if it's a number line, and that's all it is, and it's just a graph, there's no reason you have to go one direction. You can easily go the other direction back to the very beginning. I'm going to talk about two specific ways to do this. One of them, everyone I've ever talked to agrees this is the safe way to do this. With Git, you can say, take all of the changes we did in this specific commit and undo them. And then take the state of the file and make a new commit that says we undid them. Called a revert. So in this case, I am git reverting the fourth change I made. So I git revert the fourth change, and it drops me into VI, of course. And then I say, hey, I reverted that. And then I do my git log. And now I have another commit ahead of that one that says I reverted that change. This is a very safe way to go about it. If you just keep reverting back one commit at a time this way, you will just unravel, like pulling a thread when you're doing crochet, just slowly unraveling it back to where that earlier state. And there's no chance that, hey, I made a change that was dependent on something later, and now I'm confused. Won't get confused. If I reverted one of the random other commits here, that would work. Git would be like, okay, I can do that. But then we'll get to a point, possibly, of saying, but if I take that out, the change you made later makes no sense, and I don't know what to do now. And that's where detached heads come from, among other conflicts that you'll get. Be like, hey, I'm not sure what you want me to do. Because Git gets to a point of confusion and it just stops. It just tells you, I'm confused now. If you do it this way, fourth change, so if I was to revert this, then revert this, then revert this, then revert the next one, it's perfectly safe. All I get is reverts forward in time. You can even revert reverts. So if you're like, ooh, I went back one too far, I can just revert that I did, and it'll go back to the state it was. Because I'm just making more commits in the future. Even though I'm going back in time, I'm still going forward in time.
So you use new IDs.
Yeah, absolutely. So the revert is just like here. I wish I had a.
Does the revert?
I do. So oh, what's
Does
that?
the revert command require you to put a commit ID?
Yeah.
Okay, because you can't just say that and it just reverts all there.
Yeah. So if like I go back here and just say git revert, it'll be like, whoa, what do you mean? So you need to put the ID.
Okay.
Is there a way to revert just last commit?
Yeah, you just put
Sometimes you need it very fast.
Yeah, you just grab the ID from the Git log.
You have to look up that commit ID, and
Yeah.
if you really
I mean,
did something bad, like you're gonna, is there just?
yeah, you just look up, run a quick Git log, grab the ID, and pop it in. That's what you do. You do need the ID. You need to tell Git what it's reverting. There's probably a way to alias that, and there might be a plugin or something for Git that lets you do just the last one, but not natively that I know of. Not that I know of. Again, there might be a different answer to that there in the world to that. So that's the safest way to do this. You need to do it quick. Run a quick Git log, one line, grab the ID, and just Git revert back to where you were. Then there's a dangerous way to go about this, which I use personally for very specific reasons on my projects, because it just works. Git reset will go back to a point in history and forget everything after that. Except Git never really forgets. It just doesn't tell you that it's remembering anymore. Everything you do in Git is stored in the Git folder. Everything. So you can always go back to anything you ever did in Git, ever, that you ever committed, ever. But you can say, hey, Git reset, and in my Git history I'm going to show you, the Git log that I'll actually show you, I'm just going to not show you those other those IDs. So here I'm hard resetting back to this point, and sure enough, I Git log again, and I get to literally this point. And that's where it thinks I stopped. Don't ever do this on a project where you're collaborating with someone else unless you have specific instructions to do so or agreement all around that this is the right path. If you're working by yourself, though, sometimes you'll make, if it's me, I commit early and often because I know I have the flexibility to always go back in time and do this. So I'll commit early and often locally, and I'll just commit, and then I'll finally figure out what I'm doing. And like 10 commits later, I'm like, I should have just done this in the first place. Oh, I just copy that to a separate file. I'll just start a new file, copy it over, reset hard back to the original state, copy my new changes in, and for all intents and purposes, it's the same thing. Like for my local machine, I just reset hard, and now that I have one new commit ahead of where I was from wherever I'm working against remote, and push that up. For me, that's a good system. For you, you might have other reasons to do it, but there's multiple ways up this mountain of going back in time, but it's possible. There are other ways to go back in time, but I'm not going to talk about them right here. Just these are the most two common, reverting and reset hard.
So are you using these commands on your local Git?
Yep.
Or,
Git is always local.
so you're not making it reset to the...
Nope. This is everything I'm talking about right now is just 100% on this machine.
So when you said if you're working with others and you do a reset and you need to let them know,
Yep.
even though they have their own local copies,
Yep.
because
Well-
you're still committing when you push it.
We'll get to that.
Okay.
We will absolutely get to that. But it's a really good question because we're going to get to that. Not the next section, the section after, on how they all interrelate.
Okay.
And so remember that question because that will come back up. That's a good question, but we're just not there yet. Possibly the most powerful thing in Git, because so far we haven't done anything really separate than what you could do with a central controlled repository system. Here's what makes Git unique and makes it super powerful, especially for devs. Git lets you do something called branching. Branching is literally this. This is the easiest, best explanation I've ever seen in my life. Branching says, all right, we're going to make a copy of this code over in this separate reality, and we're going to call that separate reality whatever we want to call it. So here we call it feature X. You could call it new feature. You could call it testing new plugin. Whatever you want to name it, it doesn't care. There's this master reality we're on, and the only reason it's called master is that's the original name they came up with. It's just an arbitrary name. You can call the master branch you're working out of whatever you darn well please. And if you all agree what you actually are going to work on as a team is this specific branch, this branch goes to production for just to name a branch, then that's the one you work on. Like, again, this is a human agreement of what is actually the true reality timeline. You can branch off of any of the timelines, though. You can branch off any branch. It's like a tree. At the very top of a tree, how many branches do you really, really have? You get all the way down to the bottom, and you have one solid trunk. In fact, some systems even use the term trunk. I'm not going to get into the proper terminology for branch versus node versus blob and how those things dependencies hang off each other. You can go into a lot of technical things that explain that. This is more of a high level, what does this mean? And then merge is literally collapsing all of the commits you've made in that separate reality into the master reality that everybody agrees is the master reality. So a couple use cases for this, before we get into the use of it. Say you want to build a new theme. You should probably not do that in your main development branch, because your main development branch should be left clean and shippable, as Martin Fowler said, so we can not have to hot fix things. If we need to make an emergency fix on something, jump into dev, do it, and let's get it to production. Like Drupal Geddon. When the patch drops for Drupal Geddon, you don't have to think about it. It's like, all right, that just goes in. Bam. But if you're in the middle of writing a new theme and you're working on a custom module and you're also trying to implement a new contrib module at the same time, that's a mess. What do we do? How do we not ship something that's not ready? How do we take that out? What is ready to ship? Is anybody ready to ship? Having that conversation slows down the process. And you want, as pro DevOps, to just like, no, patch is gone. Patch is out there, everybody's happy, we're all good. Features let you do that. Branching lets you do that easily, because everything you do in a branch does not affect master until you tell it to merge. So if you have 3 different branches, one of them for a new theme, one of them for the custom module, one of them for the contrib module you're working on, and this goes hand in hand with configuration management, the talk that was in here before here. If you didn't see that one, highly recommend it. We can just keep those independently separate, so we can get Drupal Geddon out the door, Drupal Geddon patch out the door, and just keep working over in these other branches. Not a big deal. And when they're ready, they're finally ready, one at a time, we'll just merge them in. And then the commit history we have from working on that set of files go into the master log. It goes into that master timeline. So that's what a branch is. Like, let's create a different reality with its own log that up to that point in time is identical. We can change it independently and then merge it back in when it's actually ready to go. Or, other way, if we're working on that theme and we realize, like, this is just not working, why are we building our own theme? Let's just put Gatsby front end and be done with it. Just flush the branch. Just say, all right, this branch doesn't exist anymore, and master doesn't care. You can have a zillion branches coming off of master, and if none of them merge, doesn't care. Gets super lightweight. You can have as many branches as you want. So there's the command git branch, and if you just type that, it will just tell you what exists. And it'll say git branch, and it will say, all right, I got master. That's all I got. And then you say git branch, and you name a branch. And it says, all right, I'm going to make a new branch called that because I don't have one. If you say git branch, new branch again, it would actually say, hey, there's already one called new branch. What are you doing? I'm not going to do that. So git branch, just not, without anything behind it, is your best friend, is just checking what's going on with the branches. It will also tell you which one you're on. So this one had a little asterisk beside. Thought I turned off my alerts. Hold on. Okay. That one has a little asterisk. It means that's the one we're in. Now I do git branch, new branch here, and it will kick me branch down, git branch again to see what branch I'm in. One does not have the asterisk beside it. I am not in that branch yet. How we get to that branch is called checkout. This does not mean you're the only person that can work on it. This is a different meaning. Git checkout says, hey head, go look over here now, and that's reality. Checkout literally changes reality in your directory. And this is one of the trippy parts about Git. Git exists to explain the reality of the folder you're in, and it also can modify the reality of the folder you're in. So if I'm working in a new branch, I am still in the same directory. I'm in the exact same place on my machine. I am in the exact same tools. But what's reality in there? Git says, no, we're in this particular version of that. And that's the version control system that we're talking about. Like, we're controlling what version of reality we're actually working with. So if I git check out this branch name, now I'm over here, and I can start doing changes and work. But in my IDE, I didn't have to open a new file. I didn't have to modify where any of my tools were pointing. They're pointing the exact same folder. But inside that folder, Git says, it's this reality, not that reality. Kind of trippy, and that's one of the harder concepts to wrap your head around here. So if you're like, still not grasping that, it's cool. You will as soon as you start playing with this. One of my favorite books that ever got written is called "You Can't Teach a Kid to Ride a Bike at a Seminar," and it's true. I can tell you about Git every day for the rest of my life, and you will never get it until you actually use it. So that's why I'm recommending don't worry about the coding side of it. Just worry about making some files, updating them, pushing them, and then start playing with branching. Like if you're writing just a doc. In fact, some of the tutorials actually take you through Shakespeare sonnets. One of them that I ran through did. Where you can just like jump to a branch, and then you modify that sonnet, and you new branch, and then you're modifying the sonnet somewhere over here, and eventually you pick, I like this version that we picked, and then merge that one back in. So Git branching, we're checking out. The changes we do in that branch do not get reflected in master until we tell it to. So you can have our own branch log that is like a mile long, and that's fine. And then we merge it in. All of those commits go into our master commit. Merging, just because everything's local, it's not just local as on my machine, it's from the point of view of Git. So inside of a branch, the idea of everything is local still applies. It's still like, oh, I can see that over there. So I'm going to pull it into me. So when you merge, you're merging from somewhere into wherever you're at. So if I'm in a branch and I want to merge from master, that's totally cool. That's possible. In fact, I want to do that after I do core updates. If I'm working in feature branches, I'll just update core in my main dev branch, and then I'll push that to the other branches I'm working in and make sure it all works right. But more commonly, you go back to master, and they say, hey, merge this in from this branch. And then we get to the world of merge conflicts. Git is only so smart. It's super good at what it does, but it gets to a point of like, I don't know what to do now, and it just stops. That's what merge conflicts do. If two branches have modified the same file, so if you're in master and you modified a file, in this case index.html, and then I modify it in the branch, and then I try to merge those two together, Git's like, wait a minute, I don't know anymore. What do you want me to do? And this is what it does. It literally will write in, this is what the head says, and this is what your branch says. What do you want me to do? Now, in this case, it's super trivial to fix. All I do is modify the file the way I want it to look, git add, git commit, and I'm done. All I've done is say, hey, you took this state I didn't understand, saved it new state, and that new state, oh, I know what to do with the new state, I'm going to add and commit it. And we're back to normal. Now in this case, super trivial. If we're doing this across dozens of files, ooh, this gets painful. There are some tools to help you. In fact, Git merge tool is a built-in function that looks for a third-party tool you can install to help you deal with this. But there's also the big benefit of code reviews. You can look at code review. If you do it properly, you'll never get a merge conflict in the best ideal situation. All right, sake of time, I'm going to finish it up here. You're like, you haven't talked at all about these things, which are how everyone interacts with Git at some point. Great news. All of these are the exact same implementation of Git that is on your local machine. Git is Git is Git is Git is Git. All of these have built a service layer on top of Git that all work slightly differently, but mostly do the same things. GitLab was the first to the finish line with implementing the service worker layer that works on top of all that Git stuff to manage like how it moves around and whatnot. But that's all specific to their implementation. That's not what we're talking about today. We're talking about the basics of Git. So this all works the same. This is just your Git repository, the same as or your local directory, the same as anywhere else. All the Git commits are there, everything. And this is where the push-pull, working with remotes. If you see the slides later, this is maybe the most important slide in the whole talk. There's no one true master here. There's something called origin, because origin just happens to be the name that Git gives to the first remote repository it sees. When you make a new remote repository and say, hey, there's a clone of you over here, by default, the first thing it calls it is origin. That's just a default. You can call it whatever you want. You can call it George. You can call it, this is the right one. Pantheon, GitHub, Bitbucket. You can name it whatever you like. The more verbose it is, the longer it's type, but you'll know exactly what you're doing with it. So, question from earlier: how do we get those changes, or what about those changes we're making on other machines and whatnot? So, what we're the idea that these three repositories, like, there's no one master in charge, but we as human beings can say, the one that remote repository that we all called origin, we're all going to agree that that is in fact the true one. But that's a human agreement. That's nothing to do with Git. Git doesn't know. This one might be the true one for all it knows, or this one, or this one. And I don't know why Lighthouse is popping up there as an alt text. It's weird. This origin just happens to be, in this particular case, GitHub or Bitbucket. Doesn't have to be. It's any other machine that has Git on it that you have network access to. So this might be this machine, that might be your machine, and this might be GitHub. And that works fine, as long as you have network access to someone else's machine, and you can push and pull all day. Push means I have access to that place I'm pushing, and I have the rights to it, and it will just let me do it. I can just push it right there. Pull means I have access to this, and I can take from something else and pull into me. It's just what it sounds like. And it's, like, again, from the concept of everything's local. Pushing, I'm pushing the code away from me to something else. Pull is I am pulling it from somewhere else into me. So that's the pull-push concept. So you could remote add. You can manually do all of this stuff. Like if I'm starting with a new repository and I want to build, like on GitHub, I will manually git add, and I will git push. Origin master is the most common thing you'll type. Git push, where am I pushing it to? What am I pushing? That's all this means. So git push origin means, hey, we'll push to the default first remote that we named. And what branch are we pushing? We're pushing our master branch. Or we could push to origin just the branch that we're working on. Or we could push to another remote. Origin master is not anything special. Origin just happens to be the default. Master just happens to be the default. So we, by default, will type that a lot more. It's GPOM. Most people alias that at some point. Pull. You're only going to do this if you have rights to the repository you're trying to pull to, which on your local machine is, I did it earlier, just a git pull. It means pull down the latest, and it actually does a fetch and an update. Not going to get into the specifics of that, no time. But git pull will, like, hey, I'm going to take these changes I see over here, and we're going to make them my local. Here, I can either add commit directly to master, which I'm going to do because I own this repository. If I didn't own the repository, skip ahead. You guys get the concept of push and pull, I think. If I didn't own the repository, there's this other special thing that happens called a pull request. But rather than doing all that manual setup of like manually naming the remote, most of the time you get all of that automatically by doing git clone. It does a bunch of steps for you as a shortcut. It says, hey, make a local directory, name the thing I found, copy everything over with a fetch, do an update to make sure everything's synced, and a couple other steps that get it. Oh, name the repository origin by default. You can name it whatever you want with flags in the process, but git clone. It's a really powerful little tool. And what it does is it keeps a significant link back to where it came from as that origin, or whatever you named it. Which lets you, I'm not going to, the rest of this I'm going to use GitHub's GUI, but there's a way to do this from command line, where you can create new branches upon pushing. When you git push origin master, if you have rights to that, it will just let you do it. Otherwise, you're going to git push to a pull request. And a pull request is just a branch. You're going to have an online discussion or in-person discussion, and then merge it back together. And the person who has the rights to merge that back together, who says this can go in, is the person who owns the repository. Git doesn't care who owns the repository. GitHub cares about who owns the repository. That's a logic layer. Again, Git is always local. Like this idea of ownership, that is completely built into the logic of GitHub and Bitbucket and Circle CI. And the pull requests can exist without them, but it's way easier with them. That I can say, hey, I'm going to share this over with you. I want to make a pull request, which a pull request is literally, hey, person who owns the repo, here are my changes. Pull them in if you agree. I can't push them in because I don't have rights to do that, but you can pull them in if you agree with me. And that's what a pull request is. That's all it is. So make your branches, work in them, go push them where you can, and open a pull request and say, hey, I want you to pull these in. Now, how your team does that specifically, there will be process for that. I guarantee you, if you're working on a team that has a wiki, it's in the wiki. Someone on the team can sit down and explain this is the proper way to do it, including how to structure your commit messages, including how we want you to write, how that conversation should flow. There's processes around that. But the people that drive that are here, not here. That's the most important thing. So I didn't memorize all of Git. All I memorized was this. And in fact, for certain things with checkout, because checkout can look at anything, any commit that you've ever made, you can check out into. Ever. Super powerful. Again, a little more deep than we need to get in today. So for everything else in the entire world, I use DuckDuckGo to look this up. Not for privacy reasons. DuckDuckGo, and sometime in the last 2 years, modified their logic to do this. If there's actual documentation for the thing you're looking up, it shows you the documentation first instead of Wikipedia. And I love that. It saves me a lot of time looking things up. It's like, oh, that's how Stash works. Got it. Understand now. And I don't have to look any further than DuckDuckGo. That's just a little plug for them. But seriously, this is the best documented thing on earth. Someone's already probably made a video that explains all of this in depth. In fact, I'm always amazed that they let me give this talk because there are so many amazing free online resources. But one of the reasons I give this talk is, if you just look it up, there are hundreds and hundreds of how-to guides on this stuff. Hundreds of cheat sheets people have made. And it's kind of a blur of where to start. And for me, until I wrap my head around the general concept of forward in time, back in time, parallel universe, and what the pull request really was, it just felt really piecemeal. I never felt like I really had a grasp on what was going on and a base to build on. But knowing those basics, I can use Git because I can look up everything else. This is the part where you're supposed to clap along with Picard, but there's only 4 of you, so yeah, well, okay, thank you. But that's it. I ran out of time because I would get excited and talk about some of this stuff way too in depth. But I got time for like one question. Then I have to talk to anybody after the recording's done.
What's the difference between Git revert and Git reset?
Revert,
Revert, you go to particular...
yeah, but the rest of the history remains intact. Reset cancels out the rest of the history. So if I revert, like if I have 5 changes and I revert the 3rd one, the 4th and 5th change still exist. If I reset hard, 3rd and 4th change disappear.
So that's kind
4th
of
and 5th.
dangerous.
Oh, that's major. That's a huge difference. Again, only use Git reset if it's your project and you know what you're doing, or you have buy-in from your team that that's the right way to do this. If you're working locally and you just want to wipe out the last 10 commits because you did it wrong the last 10 commits, just reset it and it's your project. Keep going. Locally, it's fine. When you share it, that's when it gets into trouble. And it's only your commits that you're doing that against. All right, with that, I'm going to hit the button, and thank you very much.